Okay, so now let's look at the next problem. So lots of times, well, we'll see what the new test is like, but they ask you to rank numbers in order when you can't actually find a number for them, but you know if something's positive or negative. So if this is the graph of y equals f of x, and remember that's the first thing you always want to check. This is the graph of function f. They want us to compare three derivatives. So if you look at one, function's increasing. So this is a plus number. And here you've got a horizontal tangent. So that's a zero number. And at 3, the function's decreasing. So that's negative. So which one's the smallest? This is the smallest. This is the middle number. And the positive is the biggest number. And they always have them in the same order that I've seen the question. So that's good. It's always smallest to biggest. Okay, now let's do it this way. Okay, so if you look at 1, let me switch colors. Okay, so if we look at 1, let's see. The output is 0. We already talked about the functions increasing there, so the first derivative is positive. And the function's concave down here, which means that this is negative. So this is the smallest, this is the middle, and this is the biggest. All right, now let's do the next question with the same graph. Okay, so G prime is F. Okay, so like, oh, now this is a derivative graph. They do this a lot. So this is the derivative of G. So how do we know when G is concave up when we're looking at its derivative? So I'm going to write the reason first. G prime. Oh, no, let me change that. 1 second. Oh, Miss Brady, you're hysterical. Hang on. Let me just erase it magically. Okay, so let's see. G is concave up when G prime is increasing. And increasing, decreasing, positive, negative, you can look at in the graph. So this is the graph of G prime. Okay, so let's see. So up to here, it's increasing. And then up to here, it's increasing. So here's the increasing parts of the graph. Okay, so we're going to say x is less than 1.903, or x is bigger than that 5.431. And sometimes they may give you that you have to put the graph on your calculator and find them using all those cool keys we learned. All right? Okay, last one. All right, so here we go. This is the derivative. We want a relative maximum. So we know h prime changes from plus to minus because h will go increasing then decreasing. Okay, so we got this already. Sometimes you have to find h prime with the derivative, but we got a factor. Factor out an x. You get x squared plus x minus 2, which means you've got x, x, x. I think it's plus 2 and minus 1. Now, I'm just going to do this by graphing. So you know the zeros are at 0, they're at 1, and they're at negative 2. And I know this is a cubic. And the first leading term is positive, so I know it's got to look something like this. You could test some areas too, but sometimes if you know about the curves, it's easier. Okay, so we want h prime to go from plus to minus. So that is right here. So that's at x equals 0.